We've seen a few times now that energy can be transferred from one form into another form. However, it's not always transferred into the form that we intend, because most devices aren't 100% efficient. So in today's video, we're going to take a look at what efficiency is, and see how to calculate it, both in terms of energy and power. Let's start by considering a lamp. Its input energy is going to be electrical energy, while its output will be split between light energy and heat energy. As the purpose of a lamp is to provide light, we consider the light energy as useful energy output, whereas the heat energy can be classed as wasted energy, or non-useful energy output. The efficiency of a device like this is just the proportion of the energy supplied, so the input energy, that's actually transferred into the useful energy output, so transferred into light energy. When it comes to your exams, you'll need to be able to calculate the efficiency of a device as a decimal or a percentage by using the equation, which is efficiency equals useful energy output divided by the total energy input. Or if you're using power, then its efficiency equals useful power output divided by total power input. To put this into practice, let's imagine that we have two lamps, and we supply 300 joules to each of them. The one on the left has an old incandescent bulb, which converts 45 joules of that 300 into light energy. Meanwhile, the other one has a modern LED bulb, which converts 225 joules into light. How many times more efficient is the LED lamp? First of all, we need to calculate the efficiency of each bulb. For the incandescent bulb, we would do 45 joules, which was the useful output, divided by 300 joules, which was the total input. This gives an efficiency of 0.15. Meanwhile, for the LED, we do 225 divided by 300 to get an efficiency of 0.75. Then, to find out how many times more efficient the LED lamp is, we just divide its efficiency of 0.75 by the efficiency of the incandescent bulb, 0.15, which gives us 5. So the LED lamp is 5 times more efficient. If we instead wanted these efficiency figures in percentage terms, we would just multiply them by 100, giving us 15% and 75%. And we could then do 75 divided by 15 to give us 5 again. When you're calculating the efficiency, one of the common mistakes you need to watch out for is to get the division the wrong way around. If you ever do this, you should be able to notice it though, because you'll get a value bigger than 1, or bigger than 100%. In our example here, you'd get an efficiency rating of 1.33, or 133%, which is impossible, because it implies that you got more energy out than you put in the first place. And if you remember the conservation of energy principle, energy can only be transferred, never created or destroyed. Let's try another example, but with power this time. This particular microwave is 70% efficient and has a total power input of 800 watts. Calculate the useful power output. First, we need to take our efficiency equation and rearrange it to get useful power output by itself. We also need to convert our efficiency into a decimal by dividing 70% by 100 to give 0.7. Finally, we can plug our values into the equation, which would be 0.7 times 800 watts to give us a useful power output of 560 watts. Now, no device is 100% efficient, because all devices produce some form of waste energy, most often in the form of thermal energy. An exception to this rule, though, is devices whose function it is to produce heat in the first place. For example, if electric heaters produce lots of thermal waste energy, then it isn't really waste, and instead would count as useful output.